Muted.
Presentation one.
Hi, good afternoon or good morning, based on where you're joining from. Welcome to this webinar of Predictive Analytics for the auto parts industry. Uh, just a little bit of housekeeping. We will be having walk you through what is involved in auto parts. We also have a demo to show how predictive analytics work for auto parts industry. And towards the end, we will also have a session for Q&A. So if you have questions, hold on to them, or if you might see a screen for questions where you can post your questions as it comes to your mind. We will answer all the questions at the end. We've allocated time towards the end for question and answers. So with that housekeeping, let me start. A little bit about our company. Bista Solutions is a company based headquartered in Atlanta. We have 6 offices worldwide. We've been around since the year 2007. We provide ERP, BPM, and business intelligence solutions to our customers worldwide. And some of the industries which we work with is manufacturing, telecom, automotive, healthcare, retail and distribution, and education. A little bit on what we have done in BI and big data space. So we work with, we've done a lot of data ETL / data warehousing solutions for our customers. We've also worked with big data. And big data, we leverage open source technologies and stacks like Hadoop and Apache Spark. We have done predictive analytics and have a team which can actually help you in your predictive analytics or just business intelligence requirement. We work a lot on the cloud. Since our solution stack is open source, it gives our customers the flexibility of deploying these solutions either on premise or on the cloud. Now we start this webinar is about analytics. So let's just step back and see what is analytics about. So if you ask different people, each person might have a different idea about analytics, because these days you hear a lot about analytics from different sources. You know that this is important to run your business, but what does it mean? Does it mean data? Does it mean statistics? Or does it mean database marketing and so on? So to clear this, we thought it is important to step back and say what we define analytics as a company. So we define analytics as driving business decisions and delivering results through the use of data using statistical and mathematical techniques. So that is what we define analytics. And the key, as you know, is business decisions and the results, right? So that is more important. to more specifically, analytics is not just about reporting or dashboarding. It is about advanced analytics which helps you predict the future. It's not just about an IT tool or an IT system, right? You should, as a business owner or a decision maker, not think of analytics as an IT system. It is more of an organization-wide strategic capability, right? So you need to think about analytics as an organization-wide initiative. It's not about quick results. It's not just graphs. So it's not giving you quick results. It is a long-term competitiveness. And to gain competitive strength based on analytics, you have to commit to the analytics endeavor in your organization. It is not just statistical analytics. It is using these statistical techniques to get business results. Again, it's not targeted marketing. A lot of companies have used analytics for targeted marketing, but it can help improve performance across all departments in the organization. And lastly, it's not for banks or the big cable or telecom companies. It is meant for all industries. So analytics is mainstream now with all the open source tools available out there. Small to medium-sized companies and mid-market companies can take advantage of these technologies, which were limited to the big banks before. Now, while we talk about analytics, we want to just touch base a little bit on the stages of analytical maturity. And this is how an organization will go through. So they will probably have something called descriptive analytics, and a lot of companies these days have this in place. So this gives you all these graphs and dashboards, and it tells you what has happened in the past, how your sales performance has been, how your purchasing department has been faring in the past, right? But after this, once you reach this stage, the next step is the predictive stage, where you are able to use the data which you have gathered with your from your operation as well as from outside, and be able to predict what is going to happen. How is my sales going to be 2 months down the line or 6 months down the line? What will be the pricing which I will be able to sell 2 or 3 months down the line. So this is when you move from descriptive to predictive. Quite a few companies are doing the transition from descriptive to a predictive analytical maturity model. After this is what we say as the prescriptive analytical level of maturity, where you take actions on this decision. So you make it happen. Right, so you have these automated in your workflows, where a certain action is triggered based on the forecast of something going to happen. So if to give you an example, if there is maybe you identify that there is a tsunami in Japan as it happened a few years back, and that is going to disrupt my supply chain, you take proactive actions based on that predictive information which you have. So that is when you move from a descriptive to predictive to a prescriptive analytical maturity. Again, for some of the industries which have benefited and some of the areas which can benefit from this is supply chain, again, which is essentially a major topic of today's conversation, where you can optimize your inventory and reduce stockouts. People have used predictive and prescriptive analytics for customer management, to identify which customers, and that is what the targeted marketing is about. When Amazon tells you, hey, you may like this, there's a lot of predictive analytics going behind the scenes to see your profile, see what you've been browsing, what you've been ordering, and suggest you based on what people similar to you would like. Human capital is again an area where predictive analytics has been used a lot to improve the performance and help employee retention. Financial performance obviously has the financial companies have been using it for many years now, and product and service quality improvement. So now with this, we want to talk about predictive analytics for the auto parts industry. So while we talk about this, let's think about what are the challenges for auto parts industry, right? Most important is which part do I stock and how many of them, right? And how do I reduce my operational cost? As you know, auto parts industry works on tight margins, and making sure your operational cost is at its optimum is very important. How do I identify parts that are not contributing to sales? They're taking space, they're eating up cost by occupying space in my warehouse, but it's not selling. And how to keep up with the competition and price-sensitive auto markets. This is what we say, the challenges of 4P for the auto parts industry. You start with the product. You need to make sure you are stocking the right parts. You need to anticipate in advance that these parts will be actually required. You need to also plays a very important role for auto parts industry. You need to have, this industry is mostly, the sales cycle is not long. The customer comes to you, you either have the part, you get the sale, or you lose the sale. So having the right part at the right location is very important. Otherwise, you lose the sale, especially with larger wholesalers or distributors with the hub and spoke supply model. It is very essential to have the right part in the right location. Price is obviously the most important factor in deciding. People do shop around, especially on the internet, or even otherwise, people do shop around for the price, and so you need to set the right price to get that sale. And again, promotion or what time of the sale it is very important to get that right. So these are what we call as 4 Ps of predictive, of 4 Ps applied to the auto parts industry. Again, we want to talk about the multi-echelon optimization model, which has been used, and how the analytics and how it impacts your analytics and forecast. So you have multiple scenarios, whether you have a single echelon or a multi-echelon network, and this is true especially for large nationwide or region-wide distributors and wholesalers, where you might have a central warehouse, and then you have regional warehouses which are supplying to your regional locations. Now, you might want to treat each one as an individual entity and come up with the demand and stocking levels and safety stock for each of these locations. But you get a major advantage when you consider them as a whole, right? When it comes to stocking, procurement, stocking strategies, safety stock, economic order quantities. When you consider them as a whole in a multi-echelon distribution network, you gain advantage of the network. Now, this is how a multi-echelon network will help when in a distribution network. You might have multiple warehouses, right? And you have stocked all these warehouses with a certain part. Now, for a certain part, this region somehow has lower than expected demand, whereas this region has higher than expected demand. So they are running short, as you see. So in a multi-echelon, when you treat this entire, each echelon or each layer, echelon is a layer basically. So as a single unit of forecast, and you are able to move your parts from the area which is high inventory to the area where it is required, where it is deficient in inventory, and then you can get an optimum distribution network. So this is what that is the reason why any strategy which you adopt for forecasting or procurement has to take your distribution network into account and make the best advantage out of the distribution network. So now we move to our approach. So this was a little bit on theory. We move to the approach of demand forecasting, which we have used. So we take this the prediction inputs. So these might be your sales data, especially when it comes to forecast or data from other sources. We take that and we do something called as FNS modeling. It's fast, it's based on how you move, and I will get to that in the next slide. It's fast, normal, slow-moving modeling. After that, we model the seasonality. So we look at each part and see if there is any seasonality associated with the demand based on historical information. Once we have that, we add what we call as the vehicle weightage. So we take data from external sources and give a certain weightage to a certain part based on the data available. And then we use all this, and it goes into an algorithm which we have made for multivariate clustering, and which I will talk about in a minute of how that works. Once we have the multivariate clustering, we create these clusters based on different attributes of these parts. We find the algorithm or the model which fits nicely for that particular attribute, for that particular cluster. Once we have the best fit algorithm, we create the demand forecast. So that is the demand forecasting cycle, and I will talk about each step in this process in the later slides. Now, talking about the procurement forecasting, we start with the similar way where we have the demand forecast and the procurement inputs feed into our system. We do modeling of the lead time. Then we do the economic order quantity calculation based on the data which we have. We also calculate what would be the best safety stock in your multi-echelon distribution network. And we do the planning for multi-echelon that, okay, I need to basically do leveling of this part, or I need to order this part, right? So you might have some part which is actually forecasted to be sold in a different location or a different region, but you might have it and not sell in another region. So you might want to actually do leveling and not order new parts, right? So this is where you will get advantage and where you will get inventory optimization. And this actually comes up with a procurement forecast, which might actually be, hey, go and buy this, or hey, go and move this from this region or this location to the other, because this is where the sale is going to happen. This is about our FNS analysis. It's a little bit of theory, but I think it's good to know how it works. In the x-axis, you have something called the average demand interval. It essentially means how often your part is being ordered. To the right, we have something called coefficient of variation. Again, this towards the left, if you see, the blue ones are the ones where you have fast-moving parts. That you get a lot of orders of these. And towards the middle, you have where you have less frequent, and towards which we say normal. And towards the right, you have the parts which are moving slow. To the lower side, you have the ones which are consistent in the order, right? So they get ordered very frequently. There is consistency in the order. And to the top half, you see, is very erratic. Erratic in nature. The demand is very erratic. So you might get an order, in 1 week, and then week number 3, and then after that week number 10. So it is very erratic. So based on that, we try to group the parts in different clusters. We then identify patterns in the time series. So we try to see, is there a trend in your data? Is it going, this history of this part or at this location or at this region, is it going up? Is it trending up, or is it trending down? Maybe there is the part which belongs to a vehicle which is near end of its life, right? And the demand is slowly going down. Is it cyclic? Cyclic means it has a cyclical nature, but it's not constant. It can vary from 2 year to a 3 year or 2.5 year. There is some cyclical in nature. We see if there's any seasonality, whether there's a quarterly seasonality to that part. We also see if there is a monthly seasonality. So is it that this part always gets high high volume in the months of May, June, July, maybe the summer months, or maybe this part is very sensitive to the winter months, and so on. And we also see a weekly seasonality, maybe based on the type of customer you have. One customer might be, it might be a big customer which has hit its ERP or its system set to order on a certain date of the week, and you need to forecast that. And so when you are planning, you need to model the seasonality of that customer in your system. So next is the fitment application, or what we call the vehicle weightage. We get data from vehicles in operation. These are external sources of data which provides at each location. This is basically based on the registration data in the various DMVs across the country. Which vehicles are in operation in that location have been registered. We take outside data about parts fitment. There are providers which give you the part fitment data, saying that this part will be used. This is basically an oil filter part for, say, a Toyota Camry of the year 2000, right, or 2010 or whatever. So that's the part fitment data, and then we take the historical trends of that part, and we come up with what a weightage for that part. So in addition to your historical sales, we also take data outside and external and try to put a weightage so that you can predict what we say is the failure rate. It's very difficult to predict the failure rate of a part for a certain model, but this gives us a good weightage or a good indication of how we can use this information. Next, we identify the variables using regression, and this is really important. What the part you are selling at different location will have a different characteristics, right? So we try to take the different attributes which will impact the characteristic of the demand. So location is one of them. The FNS class, so whether this is at that location and for that customer type, is this an erratic fast, or is it erratic and fast and consistent, or is it normal and erratic? So we take that class as one of the attributes. We also take the seasonality parameter, which we found above, as an attribute for that part, for that location and customer. We also take the category of the part, the line of the part, and we also try to model in a similar way the price sensitivity. So once we have the product, similar to how we do the FNS classification, we also classify a product, say, hey, this part at this location is really sensitive to price, and we try to grade, put it in different category levels, very sensitive, or insensitive, and we take that as one of the parameters, and the customer type, right? This is also very important because different types of customers, the jobber would have a different kind of ordering pattern as compared to a single user or some other bigger municipality or other customer which you might have. So we take all these things, all these inputs or attributes of the demand, and we come up with and use that to create clusters on which we do a demand forecast. So your clusters will include parts which have similar characteristics, and this is what we call as multivariate clustering, which we do. Essentially, you see the parts in green, they might be completely different, but based on all the parameters you saw above, the location, the customer type, the price sensitivity, the FNS class, and so on, they might belong to different one, but they belong to the same cluster because they offer the same attribute. Similarly, red is the one which is a part, similar parts, and so on. So the purpose of this is similar parts which have similar selling attributes. would normally fit, we find the best algorithm to fit that part of class. So we don't paint every part with the same brush. We create groups of clusters which make sense, and then we try to find how to predict that part. So then we do something for each cluster which you see above. We identify the best model, the best fit model. So in this part, you see we have tried different models. Simple exponential smoothing. If you want the details, these are models which are widely available in the public domain, which we use. A lot of statistical tools include these by default. We use ARIMA, auto-regressive integrated moving average, and neural, NN stands for neural network. So for each cluster, we find which algorithm is the best fit, and this you see the error, it could be the mean absolute percent error for that cluster, and we find the best algorithm to predict that part. Once we have that, this is essentially stepping back and the overall workflow of how this prediction process works. To the left, you have your ERP, which has data, and we can integrate with any ERP, whether it's cloud-based, open source. We can integrate with those ERP systems. We need is the sales history, purchase history, some master data related to sales and purchase information. We shove that into our big data infrastructure, which we have shown in yellow. Then we use the tools to generate the sales forecast. We also feed in data from external systems, which might be vehicles in operation, which might be parts fitment data, right? We might take advantage of that and use the methodology shown above to generate the sales forecast. This sales forecast feeds in to our procurement plan, and we use the methodology which I showed above to create the procurement plan. And from there, from the purchase forecast, we also have a stock plan, and this generates a sales forecast. The procurement planner generates a procurement plan, and and we have the stock transfer plan, which actually feeds back into your ERP for further action. So based on the ERP, we can actually create files, or we can even go to the extent of automating that and confirming those procurement plans, or creating them for someone to review and then confirm. So this is the part of the entire prediction workflow. This is completely automated. So it's not, though in the demo I will show you how we handle this in step by step, but this is essentially fully automated, can work in batch mode or in real-time mode as required. So, some of the forecast improvements which we see, and this is what we can do for you, is what you see is to the orange line is the demand. The blue line which you see in the graph is the actual sales, and the green one is the forecast. So how do we know the demand? Because some customers are log what they call as lost sales. So say you have a customer walk into your store and then you do not have that part, then the rep will actually go into another screen and log that, hey, someone walked in, asked for this part, we do not have it, so lost the sales. So some customers capture it based on your e-commerce portal you have. The technology which you use should give you the capability of identifying lost sales, that hey, someone clicked on this part, tried to check out in his cart, but then it was not available. So you can get that data from lost sales. Now you see that for this particular part in this scenario, we actually were able to predict that this was the actual sales, and we were able to predict that, hey, this is how much you're going to need. So if you were to use this, you would be very close, because this was your actual demand. This is this is the sales, and this is the lost sales. So and this is what we forecasted. So if you had gone with our forecast, this would be the differential sales which you lost, which you would have not lost. For different months, we found that we were 44% up from actuals, 20%. So on average, from 20 to 40%, the sales can be increased by using our algorithm. And now at this point, I would like to say that we can actually, our team can do this analysis for you. If you have your data for the last 2 or 3 years, give us this data. We will work on it in our algorithm, in our infrastructure, and tell you that, hey, if this is the models which we've developed, and if you were to use this for the last 3 months, this is what we would have predicted using our algorithm, and this is how much you would have saved. So if you want anyone of you're interested in this kind of analysis, let us know. Contact our sales number. It will be displayed at the end. We can do that for you, and show you what benefit you can get, or you would have get if you had used our system. So this is what we can do for you. Again, some numbers about procurement improvement. You see, the green is the forecast, and blue is the actual inventory values, and the orange line is the sales. So with this, we can actually run a similar process with your data. If you're interested, we can run it, and we can identify that, hey, if you instead of a simple weighted, you might be using something to do your forecast and planning. I'm pretty sure everyone does that. You might be using a simple weighted average, just see the last 3 months sales and forecast for the next month, right? Or you might have a little more advanced forecasting methodology. But using this comprehensive methodology, which looks at the entire history, tries to identify automatically the attributes which determine the forecast, and then generate the best algorithm for each and every of these attributes, and create a forecast by aggregating on your distribution network. The advantage you get with this comprehensive approach is much better than what you would get from just a simple weighted average calculation in an Excel sheet. So if you're interested, let us know, and we will definitely be helped to do this analysis for you. So with this, we move to the demo. Once we're done with the demo, we will have questions for time for Q&A. So if you have any questions, you can continue to type on the questions as it comes up. We will try to answer them. Now this is our big data. This is actually hosted in our big data infrastructure. This is a tool used by our data analysts to view and and do some prep work with your data. Mind you, once this has been done, once we have identified the data, it can be completely automated. Okay, so now the way we work is, we take the sales data. Now this is denormalized sales data. You might have data in different systems, and in different tables in your database, whichever ERP we are using. We take that, shove it into our big data infrastructure, and denormalize it. So we have this different fields. We have the customer type, we have the segment, we have the name of the products or part numbers. In real life, it would be part numbers. The region where you've been selling, the date, which is very important, and when it was fulfilled, the quantity of sale, and the price at which you sold. So we get this data into our system. And one advantage with the big data infrastructure we have is, especially with auto parts industry, based on your size, you might be working with tens of thousands or hundreds of thousands or even millions of SKUs. We have seen that some customers have millions of SKUs, right? And then to be able to manually forecast for this gets very difficult, and that's why big data is very applicable to auto parts, just because you're looking at millions of SKUs. So this is the sales data. Here you see the fitment data. This is got from external sources, or you might have these sources in your company. You might be using it, but this tells us which part number belongs to which model, right? Which model, which car, which make, which year. This tells us that. And then we get data from other sources, external sources, which gives us vehicle and operations. So this tells us that in this county, you have so many cars of Chevrolet Camaro 2001, and we get this data from external sources. So this is the input data which we get from your ERP and your external system. Once we have that, our team does this data analysis of try to understand your data. So we select, okay, this is how your parts have been selling, and mind you, this is the initial part. The entire process is actually automated. These are my this is how my sales is. I can select, okay, show me by customer segment. Okay, this is how my sales is varying by customer segment. This is how my sales varies by my different regions in which I am. And these are the box plots. It tells us, how that particular data is spread, right? So it gives us the mean, median, the lower quartile, and upper quartile, and so on. So this is used by our data analysts to understand your data, right? Okay. So yeah, if you have any questions, just feel free to type in the questions box. I will be getting to the questions after the demo. So again, this shows you the trends of your data. I want to see by customer segment how my trend is, or I might want to see say only for my installers how my data is. I can see that and say how my installers are ordering oil filters, right? So this is what I get, and then if I say show me the quantity, it shows me the data. So this we use to identify the trends in your data, identify the patterns, identify which attributes or which characteristics determine the forecast, right, or have a bearing on how much you will basically require. Next, we do the clustering. This is the FNS clustering. So, which I said, we group your data into fast, normal, slow. So for this data set, you see we have 30% slow, normal, and so many fast. Within the slow, you have so many slow and consistent part, slow, erratic, normal, consistent, normal, erratic, normal, fast, consistent, fast, erratic, and these are the actual parts which are within that. So we use this to identify, to basically create clusters that this part at this location has this selling pattern, because that has a direct impact. If you are selling fast and consistently, how you would predict your sale at that location would be different for the same part if it were in a different location and it was erratic, the demand was erratic in nature. So the algorithm which you will use will be different. So now once we have these once our data analysts have done this analysis, we go to the forecast. So this is where we get the forecast. And this shows the best fit model. It shows for this spark plug, we tried the various models, and these are the various root mean squared errors for the different models. And we see that actually this algorithm, which is essentially a neural network, is actually good for this part in that location. Now, if I see another part, see a wiper blade, I see that, hey, Holt winter, maybe it has a lot of seasonality in its demand, right? That's why, and very, very, very truly so, because wiper blades have seasonality. So, we find that, hey, for this part at that location, the Holt winter is the best algorithm to use. And similarly for oil filter, we find this is the best algorithm. So once we have this data, once we model your parts based on the selling pattern of your business, we then create a forecast. So this is stored, and then we can run it automated and generate forecast and also validate it. So this is the forecast for this is the best forecast for the part which I had before. The blue is the actual the black is the ARIMA method, auto-regressive integrated moving average. We found that to be the best part, best model for this. And then the green is actually a forecast for the next 3 months. Okay, and if you see, this is our, this is the data which we've been working at. You see that, we basically do is validate our model which we selected against the data. So you see, it's fairly accurate, right? I mean, it's the best. We're able to, this is the accuracy of past data with which if we fit the model, how accurate it is, and then we come up with these point forecast. Obviously forecast also always has a range with a certain confidence level, but we are showing here just the point forecast. So let me switch to our spark plug and see what the data is. So now, mind you, this data will be different for different parts, and obviously your parts will be different. So don't this will not be exactly your sale because we picked up a certain location for this demo. Now this is the accuracy level for the parts forecast, and we found neural networks actually to be a good fit for this. And you see, we've been quite accurate over the past in terms of how accurately we can forecast. Like we were able to forecast at 96%, right? So just by taking your historical data, creating a model, and then running the model again on the historical data and seeing if we were to run this model at the end of January, we would have forecasted 165, but at the end of February, you actually had 160. So our accuracy was 96.8, which is not bad at all, right? And this is the forecast for the next 3 months because the data set we have is only until September. So the next 3 months or last 3 months of the year, we are forecasting these many parts, and this is the graphical part. Again, this is the last part. This is the output of the data, which actually feeds into your ERP, and you can have you can create procurement forecast or whatever based on that. So now is the time for Q&A. We'll move to Q&A, and let me just see in my screens if there are any questions. There are some questions. Okay. So okay, so I'm running a company and we do have data of almost 10 years. Will I be able to predict the demand for the next upcoming years? Which product I have to make more stock in which I can? So someone asked that they're actually from is that same person? Yeah, from is asking if there is they have data worth of 10 years, and will that be enough to predict? So essentially, that's a very good question of how much data do I need to forecast? So yes, we definitely need historical data. The more data you have, the better it is. I mean, let's put it that way. If you have 10 years of data, it is really good. So we need to be able to forecast 3 months down the line. Different people, it depends, but you generally like to have at least 10 months of data at the back to be able to forecast for 3 months forward. So this is what there are different thumb rules, but the more data you have, the better it is. Now with 10, we have to understand that this is an iterative process. So we will be our forecast looking 3 months into the future will be more accurate, and then the level of accuracy will go down as we look 6 months or 1 year into the future. But this is not a one-time process; it's iterative. So as you sell for as you complete 1 week. Or we can do it on a batch basis also. maybe say assume you ended the month and then you shove in the data and we calculate and see what is the next, based on the information so far, what are the next 3 months. So the further you see in the horizon, the level of accuracy reduces, but you might just be interested in the next 3 months or 6 months for your planning. So definitely having data can work, and we can definitely work with you. Contact us with more information, and we can help you out. Okay, and then someone else asked, do the results improve generally over longer time periods, 10 years for example? So I think I might, yeah, I answered that. Yes, if the data, the longer the data you have, the better it is. But say you have seasonality in your data. These algorithms are smart enough to give a certain weightage, to the more weightage to the earlier years than the years which are further down in the past. So if you are predicting for 2016, it will definitely consider your sale in 2010, 11, 12, 13, 14, 15, see the patterns, trend, cyclical nature, identify those. But they are smart enough to give more weightage to the earlier years and than the later years. But it definitely helps. I believe that. I hope I answered your question. If not, you can type again. So if there are any more questions, you can just type in. Actually, that's very, very good. Having a lot of data is actually good. Sometimes customers come with data, and they might not be logging. They might not be logging the data. Like I mentioned about lost sales. So some customers are smart enough to have logged their lost sales, whereas some people are not do that. Okay. So yeah, someone asked, I'm using iCharts. How this is different from yours? So iCharts is essentially an as I said, it's more like a reporting and dashboarding tool. What we are talking about, it doesn't depend. The visualizations which you saw is not important. It's just used. We can use any tool to visualize the data. It is it's these algorithms which are more important to forecast, and it's more. You cannot just use an out-of-box tool to predict, because you need to characterize your sale, right? And our premise is that each business is different. The auto parts industry is different, and the way you predict in auto parts industry would be different from what you would do in a garments industry or what would you do in an electronics industry. So you cannot use an out-of-box tool without tweaking it to fit the pattern of data of your business. Like auto parts, is very cyclic in nature, very price sensitive. It is, there's definitely a trend, because vehicles have a life cycle. Vehicles might come, they come in operations. Once they operation, typically after 5 years they need servicing, and then after 10 years it's used. So one more question is, how ETL is used in predictive analytics when there are multiple sources of data? So this is also a good question. So when we get the data into our infrastructure from your ERP, we can pull in data from multiple sources, and this is a part of integrating your current infrastructure in the cloud, right? So you need not replace your ERP, which is actually not very easy. You need not change your ERP to take advantage of this. We can integrate by various means, and our teams will work with you based on whether if your ERP supports APIs, we can work with those APIs. And essentially ETL is part of the big data Hadoop infrastructure, which we use. So what is the cost and implementation timeline for a mid-sized company? Good question. I can't answer. I can't answer that right now. I mean, I can't give you an exact question. We'll really need to talk to you and understand, your business. Mid-size also is a relative term. For different people, mid-size is different size. So we'll definitely call. But typically, it might be anywhere between 3 months to plus project, 3 to 6 months project, because it's an iterative process, and as I mentioned earlier, you need to take it through your organization. Any examples of other industries where this is applicable? So yeah, a large number of industries where you have your demand pattern is not consistent, right? Where you or your supply chain has a lot of variations, right? So you need, though your demand pattern might be consistent, the supply chain is very inconsistent. So you might need to you might need to buffer that inconsistency in your supply chain to use this. So in that case, it will be the best choice. So essentially, we can, like, for a telecom industry, right? You can actually use this data, use the pattern of usage to predict churn. So we can use that, the predictive analytics, to predict churn in the industry. There are a few more questions. Okay, so is this a software license or a consulting engagement? Who handles changes to the business over time? Okay, that's again a good question. So as we told, this is we are Bista Solutions. Basically, our goal is to improve efficiency in your business. So we don't sell software licenses as such. These we think we are confident that it's not a one-size-fits-all. We cannot sell you something out of box which will work for you. We need to understand your business, see what are the challenges you face, and then cater this solution for you. So this is definitely a consulting engagement. Once we define this, and the next part is who handles changes to the business over time. Again, this is a very good question, because your buying pattern might change, right? So a part which might be fast and consistently selling at a certain location might suddenly go to fast and erratic because someone else has opened the store besides you, and then it's like competing against price. So then in that case, you want to be in a different band and different algorithm. So you want to continuously review your policy or the algorithm. So when we write the code, we have this tool where we actually review that is this still the right question, is this still the right thing to attend? I mean, is this still the right model for this particular part? So we do this over time, and again we can have you can actually take our maintenance service where we can work with you if there are major changes. I see. Okay, so there's one more question. I see you have active vehicles into consideration. What if we don't have? So it's not necessary, to have the vehicles in operation. Again, there are, these normally customers do not have this data. This data is got from external sources. There are, if you search vehicle in operation, there are multiple data sources available. So, I mean, the way it works is these companies have tie-ups with all the DMVs across the country, and then as vehicles are registered, they know the data they aggregate the data and do that. So if you don't have and you want to buy it, you can that we can certainly help out with that. And if you don't have and it's not relevant to you, you need not use it. Yeah, let me see if there's any more questions. difference between, that's a good question, difference between what if analysis and predictive analysis. So what if analysis actually is predictive analysis in a way. It is actually a predictive analytics, and what the what if tool in Excel would give you was like a poor man's predictive analytics, definitely. But as we said, it's more about categorizing the attributes, identifying automatically, because you're selling millions of parts. It's not humanly possible to identify each part. These are the different attributes. So, you need an automated system which can automatically cluster your parts or your products which you're selling based on your data, and find this is the best algorithm to use, and then predict for it. So, yes, what if analysis is similar to predictive analytics, but what we are talking of here is the entire automation of this predictive analysis piece. So yeah, I guess that's all. If you have any questions, you can contact us. I am displaying the, you can just email at sales@bistasolutions.com. We can work with you. We can, certainly come and talk to you and work with your data and show you how predictive analytics can help improve your sale or reduce your inventory carrying cost. Okay, that's it. Thank you everyone for attending, and have a good day. If you have any questions, please feel free to contact us. Thank you. Bye.